Time now to explain to future secondary educators how linear algebra is helpful in transformational geometry. And it turns out, somewhat surprisingly, that if you know what the vector 1, 0 does, and you know what the vector 0, 1 does, under the transformation in which you are interested, you can create a 2x2 matrix that will transform anything you like in the coordinate plane in that way. So let's think about, let's think about what happens if you want 1, 0 to stay 1, 0, and you want 0, 1 to stay 0, 1. We would set up this matrix where 1, 0 stays 1, 0, and 0, 1 stays 0, 1. That's a column vector. That's a column vector. This is the identity matrix. Well, what happens if you multiply the identity matrix by a matrix of coordinates? Nothing. And that makes sense because the identity matrix is the transformation that does nothing. Okay, well, let's make this, oh golly, let's make this just a little bit more interesting. What if we want to do a reflection over the x-axis? If we do a reflection over the x-axis, the vector 1, 0 remains the vector 1, 0. The vector 0, 1 becomes the vector 0, negative 1. And so the matrix 1, 0 as a column vector, 0, negative 1 as a column vector, that matrix will accomplish a reflection over the x-axis. If we multiply this matrix by a matrix of coordinates where the coordinates of the vertices are column vectors in some 2 by whatever matrix, the product of this matrix with that coordinate matrix will result in all of those coordinates, the images of all of those coordinates after a reflection in the x-axis. Similarly, what if we want to reflect in y equals x? Well, if we want to reflect in y equals x, 1, 0 becomes 0, 1, and 0, 1 becomes 1, 0. So now being careful, 1, 0 became 0, 1, that's a column vector. 0, 1 became 1, 0, that's a column vector. This is the matrix that will reflect over y equals x. Your turn. Time for an on your own. What's the matrix that reflects over the y-axis? What's the matrix that reflects over y equals negative x? Take the exact same approach, hit the pause button. Let's see what happens. So there you have it. The reflection over the y-axis, 1, 0 becomes negative 1, 0. 0, 1 remains 0, 1. 1, 0 becomes 0, negative 1. 0, 1 becomes negative 1, 0. Those are column vectors. I will note as a side note here, the determinant of all of these matrices, the absolute value of the determinant of all of these matrices is 1, which makes sense because all of these matrices represent isometries. And so if the determinant were some number other than 1, when we multiplied, there would be a scale factor. It would change the size of the image from the pre-image. These are all isometries. So what happens if we want to rotate? Let's imagine that we want to rotate by some angle theta centered at the origin. Let's imagine. We're going to center at the origin, rotate by an angle of theta. Well, then what happens? This is the vector 1, 0. This is the vector 0, 1. But when we rotate, like so, that's some angle theta, and we rotate like so, that's the same angle theta, right? So we're looking to see what the image is. What happens to 1, 0? Well, this has length 1. This side right here, that's the cosine of theta. And this side right here, that's the sine of theta. So the matrix is made up of two column vectors. This column vector is what happens to 1, 0. Well, what happens to 1, 0 is it becomes cosine theta sine theta, right? It's over and up. And then over here, the same kind of thing happens. If we drop the thing here, this is sine theta, this is cosine theta. So what happens to 0, 1? 0, 1 goes left sine theta and up cosine theta. Left sine theta and up cosine theta. This matrix has a determinant of 1. It represents an isometry. It's the isometry that rotates by theta centered at the origin. So, I mean, we could memorize this and it'd be fine to memorize this, or we could learn the process of recognizing where does 1, 0 go, where does 0, 1 go, because those form a basis. If we know what happens to those two, we know what happens to everything. I hope that's helpful and a nice look back at some linear algebra. We'll see you in class. Looking forward to it.